What can you use to speed up a reaction that doesn't actually get changed or used up in the reaction? Roll that graphic. Hi, I'm Paul. This is Science That Sticks. In this session, I'm going to talk about catalysts and catalysis. A catalyst is a substance that will speed up a reaction without itself being chemically changed or altered. Easy enough. But there's more to it than that. Of course, you've got to explain what it is that a catalyst does, particularly if you're a higher tier student. This doesn't matter if you're triple or combined. The description's the same. And that description is this. A catalyst provides an alternative reaction pathway by lowering the activation energy. Therefore, the reaction speeds up. Okay, fair enough, easy enough. Then you've got to draw it as a reaction profile diagram. That's easy too. Let's have a look. Let's say you've got a reaction profile diagram. Energy is on the y-axis, the progress of the reaction is on the x-axis. For making matters easier and I just can't be bothered with doing both. So I'm just going to do an exothermic reaction profile. My reactants are on the top. My products are of a lower energy and are on the bottom. My activation energy is going to be like this. And I'm going to draw a few dots. Now, ideally, they should be at exactly the same level. If I was doing this in an exam, I'd use a ruler because I need to prove to the examiner that I know what I'm talking about. And of course, I do know what I'm talking about. Now, this part here is the activation energy, which I'm going to abbreviate to AE. Now, if you've got a catalyst with this particular reaction, you're lowering the activation energy. So the activation energy is not going to be this high. It might be that high. And of course, this is now the activation energy with a catalyst. Shortened catalyst to cat. Okay, so it's not particularly difficult for anyone to understand. So, is that it? Technically, yes, but there's a few other things I always like to point out to students, GCSE or A-level, doesn't really matter. First of all, remember, a catalyst is a substance that does not itself get chemically changed or altered. It might be changed through the reaction and then regenerated, but it doesn't get changed or used up in the reaction. That means you can get it back at the end. I'll discuss how we would do that in a moment. The other part of this is that it lowers the activation energy. This means that more particles will have sufficient energy or the minimum amount of energy for successful collisions to occur. Therefore, more collisions, more chance of good successful collisions where bonds are broken, bonds are formed. It's nice and easy. In biology, they call these substances enzymes. I'm not interested in enzymes here. I will do another video in biology in the next few weeks or so. I shall start doing more biology for that as well. But that's it for chemistry. But of course, how do you get your catalyst out? Well, there's actually two types of catalyst, homogeneous and heterogeneous. Homogeneous means it's in the same state as the chemical reaction. So if you've got two liquids reacting together and your catalyst is a liquid, then that is a homogeneous catalyst. Getting that back is going to be pretty difficult. And of course, those sorts of catalysts tend to be rarer in examples for sure, but also in industry. And the reason for this is you want your product. And if you've got to separate it from the catalyst, that's no good. So you need the other types, which are different, heterogeneous. So for example, making ammonia from nitrogen and hydrogen, that requires an ion catalyst, which is a solid. That is a heterogeneous catalyst. And that's easy to get rid of because you're dealing with gases. That's a solid, you just take it out. Okay. Other things you would filter if it was liquids on a solid, and there we go. That's it, piece of cake. That's pretty much it for catalysts and catalysis. Until next time, ladies and gentlemen, stay cool. Do your best. Bye for now.